Hello, Calculus 1 students. I thought I'd help you with this. This is the last problem on your test you're working on. This is number 11. And this is actually it, so I thought I'd try to help you with it. You know, it said there's this population of elk, and this is the equation, 250 over this 1 plus 4 e to the negative t over 3. So it asks about find the rate at which the population is growing. You know, of course, the rate at which the population is growing is the derivative. So I need to do a derivative. Now, you could do a quotient rule, but you kind of don't have to. Look what I did. I rewrote the function. I moved this up, this denominator up. It's 1 plus 4 to all to the negative 1. And I don't have to do a little product rule or quotient rule. I can just do a chain rule here, bring the negative 1 down. So here I am doing the derivative. Bring the negative 1 down, negative 250, this stuff to the negative 2 power. Then you got to do the derivative inside, which is the derivative of that 1, which is nothing. That e function is right there. And then the little chain rule on that spits out a negative 1/3. So there you go. The derivative is finished. I cleaned it up by multiplying all this in my numerator. What did I call that? A positive 1,000 over 3. Positive 1,000 over 3 e to the negative t over 3 all over this thing squared in the denominator. So that's my derivative, and that's the rate at which it's growing. And the question is find the rate at which the population is growing when t equals 2. So I plug in a 2 into this derivative. I used my calculator, and I got this answer. Basically, that's the rate of growth. That's the slope of the tangent line at that place. You know, by the way, here's a little picture of this function. This population of elk is growing. It's approaching kind of an asymptote at 250 there is what it's doing. That's kind of interesting. The limit as t goes to infinity is 250. So this is an example of a problem we look at a little bit up in Cal 2 when we start chapter 6. But anyway, cool. Now the next question says, at what rate sorry. When is it growing at the steepest rate? And you know that when is the rate the max? When is the rate the max? Which means when is the derivative the max? Which means I need a second derivative. Basically, that's an inflection point. I talked about that maybe in a previous video, different problem. So I'm looking for when the rate of growth is a max, which is the steepest place, which is the inflection point. So guess what? I need a second derivative. That's quite a bit more of a challenge. To do a second derivative, I did do a quotient rule. Here it is. What did I do? I did the derivative of the top, which is kind of easy. It's itself, but it spits out this negative 1/3. I wrote down the bottom. This was squared. Hang on. This was squared. I wrote down the bottom minus. I wrote down the top. And I took the derivative of the bottom, which brings the 2 down. This thing's to the first. This thing is to the first. And then the derivative inside, another little chain rule action there, all over the denominator squared, which is this thing squared to the 4th. So it was to the 4th. It was squared. This is to the 1st. But because I've got this term, this 1 plus 4 e to the negative t over 3, here it is. I can cancel this. Cancel one of them there, leaves me 3 of them. Cancel one of them there, leaves me 1 of them. And cancel this whole thing here, it's gone. And then I did some fancy factoring. What did I factored out this. 1,000 over negative 9, or negative 1,000 over 9, e to the negative t over 3. I saw it here. I also see it here. So I factored it out. That left me with this term, minus whatever's left over here, 8 e to the negative t over 3. It left me with this term minus this term, with this factored out front. What's nice about that is I'm looking for the inflection point. I'm setting this equal to 0. The denominator, I don't have to worry about when the denominator equals 0. I'm worried about the numerator equaling 0. Guess what? This never equals 0. So it's all about this equaling 0. When you combine like terms, this is 1 minus 4 e to the negative t over 3 equal to 0. That's pretty easy to solve. I moved the 4 over, divided by 4. I took the log of both sides. I just found t. And t is this number, which when I punch it in a calculator is this many years. 4.16 years. What is that again? Oh, the inflection point. That's when the rate of population growth is the steepest. The population is increasing most rapidly. Anyway, good luck on your, that's a good question. It's kind of a tough question. All that derivative work was kind of tough. Of course, I always find the easy way to do it, I think, with my factoring and stuff like that. So, good luck. Thanks.